The pursuit of full autonomy isn't just an engineering problem anymore. It's really come down to a fundamental strategic decision, one that's all about perception, reliability, and ultimately trust. And this single decision is now splitting the industry, defining the core architectural bet that every major player is forced to make. So here's the core question we have to tackle. Can you solve the long tail of edge cases with data alone? I mean, just sheer volume of data. This single architectural decision has created two really competing philosophies. And frankly, each one is a massive bet on what the future of perception systems is going to look like. On one side, you have what we'll call vision-only purity. This is the belief that if you just collect enough data, you can solve perception using only cameras. But on the other side, you have multi-sensor redundancy. This philosophy argues that for anything safety critical, you absolutely need a fusion of systems. Cameras, radar, and LiDAR all working together for constant cross-checking. Okay, so let's start with the vision-only approach. And of course, the main champion here is Tesla. Their entire strategy is built on one thing, leveraging the unbelievable scale of data coming from their fleet of cars already out there on the road. And when we talk about scale, the number is just staggering. We're talking about nearly 10 billion miles of FSD data. That gives their neural networks this enormous library of driving scenarios. The whole idea is that quantity eventually creates its own quality. But has it actually been enough to solve the really fundamental problems? You see, despite that massive data advantage, the system really seems to have hit a performance plateau. Even with the very latest software, we're still hearing reports of these persistent issues. And we're not talking about complex, high-level decision failures here. These are fundamental vision problems. Things like getting blinded by sun glare, struggling with ambiguous road markings, and maybe the most jarring one, incidents of phantom object avoidance. And that quote you see there, it really gets to the heart of the problem. These phantom braking events, they aren't just a minor inconvenience. They directly attack user trust in the system's reliability. And that right there is a major vulnerability for any vision-only architecture. So that brings us to the other side of the bet, the alternative strategy. And a great example of this is Nvidia. They're coming at this with a totally different architecture, one that's built from the ground up around this core principle of redundancy and verification. At the heart of their approach is something they call the safety layer. Now, this is a parallel perception model. It uses radar and a LiDAR, and this is key, it doesn't use them as the primary way of seeing the world. Instead, it uses them as a verification system. Its only job is to check and validate what the main vision-only model is seeing. So here's how it works in practice. First, the primary vision model does its thing, interpreting all the camera data. At the exact same time, a secondary sensor model is building its own, completely independent picture of the world using radar and LiDAR. Then comes the most important part, the safety verification. If the vision model says, hey, there's an object here, but the sensor model doesn't see anything, the system can flag it as a potential phantom and stop the car from doing something, well, jarring. It's basically a built-in fact checker. Now, for a long time, the main argument against having all this redundancy was simple: money. The unit economics just didn't work. LiDAR, in particular, was way too expensive for a regular consumer car. But that entire cost structure has now been turned on its head, and it's completely reshaping this whole strategic debate. Just look at this timeline. It really shows how quickly this technology has become a commodity. Think about it. A decade ago, putting LiDAR on a mass-market car was unthinkable. By the early 2020s, it started making sense for commercial robotaxi fleets. And now, we're at the point where it's actually becoming affordable enough for the car you and I might buy. And this is the number that changes everything: $400. At a sub-$400 unit cost, the impact on the total bill of materials is suddenly manageable. The whole cost-benefit analysis just flips. I mean, think about it. A safety-critical sensor now costs about the same as a premium sound system or some other optional upgrade. So the implication here is pretty obvious, right? The main economic reason for going with a vision-only strategy is quickly disappearing. When a critical safety layer gets this cheap, the question is no longer, can we afford to put it in? The real question becomes, can we afford not to? Okay, so this collision of falling costs and new technology is leading to some very different go-to-market strategies from the major players in this space. And this chart really lays it all out. You've got Tesla, still squarely focused on the consumer market with their vision-only approach. Then there's Waymo, who's been using a multi-sensor system but aiming at commercial ride-sharing. But the real game changer here is Nvidia. They're bringing that same multi-sensor, redundancy-first architecture direct to the consumer market. And that is a direct challenge to Tesla's entire philosophy. Which brings us to the final big strategic question. With sensor costs in freefall and the limitations of vision-only becoming clearer, you have to ask, is multi-sensor redundancy just the inevitable end game for mass-market autonomy? Honestly, the direction the market takes over the next 2 to 3 years is probably going to give us a definitive answer and decide which architecture wins out.